Okay, we've got part 1 of the review, and I'm going to do the first 9 questions. And so, number 1, it just says Ellie works as a lifeguard. She's making $9.50 an hour, and it says fill in the table to show what she'll make. So I've already put in the $9.50 for 1 hour. So if she works 2 hours, she should be getting paid $19. If she puts in 3 hours, it's $28.50. And then 4 hours of work, they would pay her $38. And then if she works a 5-hour day, they're supposed to pay her $47.50. And it says independent quantity would be, even though they labeled this with an H and a D, think X, think Y. And so the independent are the number of hours she works, because her paycheck depends on that. So the dependent is the amount of money. And write an equation. Again, equations are always going to work X to Y, or in this case, H to D. We're not going to go down the table, we're going to connect our X's and Y's. So we're taking our hours and we're multiplying by $9.50. So if we write it with a Y, we're going to write Y equals $9.50 times X. If you used the H and the D, it would be $9.50. And if, again, you may see it written without the zero, it means the same thing. $9.50 an hour gives you D, the dollars you earn. Okie dokie, the next one. So the graph shows the cost of the single dip ice cream at Braum's. And so, again, they already have the X and the Y on there for you, but in case you get confused, do what they do in your science class. This is dry, so that's dependent. So you know this is going to be independent. And it says, which point on the graph shows 4 as the independent quantity? So we have a 4. And if we go up, there he is, point D. Next. So we have an equation, y equals 2/5 of x, to create the tables, the values in the table. And it says, which one is wrong? So hopefully by now you know 2/5 is the same as 4/10. So 1 times 4/10 is 4/10. That's looking good. 2 times 4/10, 8/10. 3 times 4/10, 1 2/10. And then, if you know 4 times 4 is 16, you should recognize there's an issue. This should be 1.6, and they got a 1.8 there. So this one is incorrect. Incorrect. But next page. Okay, now we have 2 people, and we're looking at ages. Santiago is 4, Veronica's 8, Santiago's 8, Veronica's 4. Looks like we've got a 4-year age difference. That's not hard to figure out. You just got to pay attention to your variables, because it's Santiago plus 4 equals Veronica. So Santiago plus 4 equals Veronica. So when we go down below, I find this situation right there. So you should have chosen A. All right, we've got babysitting. And the general idea here is she's going to make $8 for each child. It says create a table to show the amount of money that she's going to make for babysitting 1 child. So this is a $5 an hour situation. So this is 1 hour, $5. 3 hours, 15. 5 hours, jump to 25. We keep multiplying by 5s, and there's our table. And then it says to write an equation. I'm going to go ahead and do that while we're looking at the table. So if this is our x and this is our y, we're multiplying by 5. So x times 5 equals y. And the standard form to write it algebraically would be y equals 5x. So let's go over there. We'll get this part over with. And then now we build a graph. This is a multiplication situation, and let's see, I believe we're supposed to label the each axis. So the independent variable is the amount of time you work. So these are the hours you babysit. And then, because I'm writing with a stylus, I'm trying to save time. This is money earned. I'm just going to use the dollar sign. So check out how they're counting. They're counting by fives up the y-axis. 1 hour, $5. 2 will be 10. 3 will be 15. 20, 25, 30. It grows by $5 per hour, just like it should. And then if you connect these points, you see the linear relationship. And so you can use a graph to go, well, if I work 7 hours, oh, $35. 10 hours, oh, 50. So the graph tells the story. Okay, going shopping. Clothing store. We have regular price and we have our sales price. Well, as you would expect, the price is going down if something's on sale. So it goes from 18 to 12, 24 to 16. So if we were subtracting a 6, that doesn't work because 24 minus 6 is not 16. So we must be using either division or multiplication of a fraction. So as we look at this, something's happening to make us go from 18 to 12, 24 to 16. And what you can do is you can set this up algebraically. I mean, 18x equals 12. 18 times something, or something's happening multiplicatively. It's division. There's just something happening to make this 12. So if we isolate our x, if we divide by 18, we see that this relationship is being changed by using 12/18. Well, we can simplify that, and the simplest form would be to divide both numbers by 6, and you get 2/3. So 18 times 2/3 gets us 12. 24 times 2/3 gets us to 16. So how do we write this as an equation? Again, I know you're used to thinking of x's and y's. They've given us r's and s's. So sales equals 2/3 times the regular price is how you would write the equation. And again, whenever you set one of these things up and you're wondering whether it's really right or wrong, you can substitute. So like for instance, I'm going to make this a little bigger. Let's use the 27 and see what happens. Okay, so our equation is 2/3 times our regular price. So if I pick the 27, let's see if we do the math and get the 18. So 3 divided by 3 is 1. Goes in there 9 times. 9 times 2 is 18. Yay! So that is the correct equation. Next problem. Oops. Let's go back to normal here. Okay. Electoral votes is equal to the total number of senators and representatives. So if you have one representative, you get 3 votes. 2 goes to 4, 25 to 27. So as you look for a pattern, it appears we're adding 2. So again, that's not hard. You just have to pay attention to who's getting the 2. So representatives plus 2 gets us our votes. So it also helps you that there's only one representatives plus choice. So pretty easy problem there. So we got 2 more and we're done with this section. Okay, the graph below shows the rate of walking. It's minutes per feet or foot. So, oops, let's move this around a little bit. So if you're just looking, which one is an ordered pair, you just got to do some plotting. And so let's take a peek at this. So 2, 100 is looking real good. That's our first choice. So let's just double check. 3, 200 is way up there. 4, 250 is kind of in here. And 8, 500 is way up there. So definitely A is the right choice. Okay, number 9. Students to teachers. The table above shows the relationship. So again, you kind of got to examine the pattern. 30 students to 2 teachers. I can subtract 28 and get the 2, but that doesn't work anywhere else. So let's just take a look at this. Teachers times 3. Okay, 2 times 3 is not 30. B says teachers times 15. Well, 2 teachers, 2 times 15 is 30, 3 times 15 is 45, 6 times 15 is looking like 90, so B is looking really good. I'm going to go ahead and circle it. 8 plus 28 is not 120, and 8 plus 42 is also not 120, so it's clearly number 9. So that would be section 1.